Hello everyone. Today in this video I'm going to show you how I solve Codeforces round 716 div 2 first problem, perfectly imperfect array. So let's first understand the question. Given an array A of length n, we have an array A of length n. Tell us whether it is a non-empty, whether it has a non-empty subsequence such that the product of all its elements is not a perfect square. Okay, let's consider this as an array, and it is asking us if there exists such a subsequence. Let's understand what is a subsequence first. Subsequence can contain consecutive elements which are not consecutive in the original sequence. Subsequence which consists of a consecutive run of elements from the original sequence, such as BCD, from ABCDF. This is BCD. BCD is a substring. So subsequence is first understand the difference between subsequence and substring. Uh, if this is an array, let's consider 1, 2, 3, 4, 5, 6. If we had to make a subsequence, then its examples would be 1, 2, 3, 5, 1, 3, 6, 2, 5, 6, like this. So the elements are not consecutive in the main string, main array. But if we consider a substring, then it would be consecutive. 1, 2, 3 is a substring, 2, 3, 4 is a substring, 4, 5, 6 is a substring, and so on. So what the problem is asking, subsequence B of an array A, if B can be obtained from A, let's say this is B, some subsequence B can be obtained from A by deleting some, possibly 0. On all substrings are also subsequences, I guess. Let's check. Yes, a subsequence which consists of a run of elements. So substring is a part of subsequence. So this is also a subsequence and also a substring. It is a part of it. So that's why it is saying it could be a substring or it could be a subsequence. The first line contains an integer t test cases. Then each test case contains an integer n, the length of the array. Test case length of the arrays, then array elements. Okay, output if there is a subsequence of A whose product isn't a perfect square. Let's understand what is a perfect square. 25 is a perfect square since 5 into 5 equal to 25. If we multiply this same number twice, or 5 square is equal to 25. Any number square, if it is a square of any number, then it is called a perfect square. Like 6 to the power square is 36 is a perfect square. 7 square 49 is a perfect square. So the question output should be if there is a subsequence of A whose product isn't a perfect square. Okay, let's consider this array. There would be 1, 5, 4. Serious this. It is saying that if there is a subsequence of A whose product isn't a perfect square, print yes. So this array subsequence would be 1 itself, 5 itself, 4 itself, then 1, 5, 5, 4, and the 1, 5, 4 whole. This is a string, original arrays. These are the subsequence. So it is saying isn't a perfect square. If any number within its subsequence isn't a perfect square, then print yes. So obviously, one is not a perfect square. Is one a perfect square? Yes, one is a perfect square. One is a perfect square, so still we can't print yes. It is a subsequent array whose product isn't a perfect square. 5 is not a perfect square. We found one element which is not a perfect square. We only need one. If we find any one element which is not a perfect square, we can print yes. Not perfect square, print yes. So the output here is yes. Okay, for the second test case, 100, 1000. All numbers which are divisible by tens, like 10, 100, or all numbers which are divisible by 100, like 100, and this is 10,000, which is also 100 into 100. This is 10 into 10. So these are all perfect squares. This is also a perfect square. This is also a perfect square. Since both are perfect square, we have to print no, as we couldn't find even one element. Couldn't find one element which isn't perfect square. So what my code is, let's see my code. This is a function which Boolean function, user defined Boolean function, which checks if this number n is a perfect square or not. You can find this code in Google itself. If you search user defined, just search for why the program to check if a number is perfect square or not. Then I got this function, then I just inserted this. Then I use this function over here. I first initialize a variable called flag with 0. Then taking the input and the vector or array, whatever you use. Then I'm checking for each elements of the array if it is a perfect square or not. This for loop or this is array equal to, let's consider this is an array. Now I'm inputting each element of the array inside this function, check perfect square. Array I. And our question said if any one element of the any one subsequence or any one element of the array is not a perfect square, then print yes. So if the number that goes through this function is not a perfect square, then it will return 0. So if it is not a perfect square, then it will be, return 0 and it will be equal to 0. This condition would be true, then we can print yes. Print yes, then change the flag equal to 1, then break. We already got our solution. Until we get the solution, this for loop will continue and check each elements of the array. After the for loop, if flag remains 0, means if we did not find any perfect square, any number which is not a perfect square, if all the number of all the elements of the array is a perfect square, then this flag will never be equal to 1 and will never print cout yes. This condition will never be true. So we need to now print no. For printing no, we check if flag equal to 0, this will remain 0, then we can print no. This is what I did. Let's see the tutorial. They did a bit differently. They use bit manipulation. Anyway, I hope you understood my problem. Now what I did here was I did not check all subsequence. I only check what I'm trying to say is, let's consider these three numbers, 1, 5, 4. I only check individual elements and not their subsequence. See, in this question they said a sequence B of a subsequence B of array A whose product is not a perfect square, such that a subsequence product of the elements of the subsequence is not a perfect square. So I could have also checked for 5 and 4. Now I have to multiply this, then check. We don't need to do so much of calculation. If all the elements are not, if we find one such element which is not a perfect square, then we can directly print no. Not perfect square, then we can directly print yes. If all the elements are perfect square, then also combining two perfect squares would also give us a perfect square. So no point in checking if all the elements of the array are perfect square, then it's automatically we have to print no. No point in checking their subsequences. So the main trick here was to check only their individual elements. If all the individual elements are perfect square, then we have to print no. If not, if any one element is not a perfect square, then we have to print yes.